Hello, everyone, and welcome to today's virtual training seminar. Passwords are not all they are cracked up to be. I am your host, Paul Asadoorian, joined by our fine friends at Online Business Systems, who we collaborated with to put this training together today. Folks on remotely, if you could do the honors of introducing yourselves and your name and title, that would be great.
Yes, my name is Rob Harvey, Managing Director with Online Business Systems within the Risk Security and Privacy practice.
Yeah, my name's Adam Kehler. I'm a Principal Consultant and Head of Health Information Security, also at Online Business Systems.
And I'm Warren Campbell. I work in the technical service team at Online Business Systems. I'm a senior consultant focusing in penetration testing.
Fantastic. Thank you for joining us today. I'm very excited. Just a quick agenda. The first part of this will be a little information about Online Business Systems in case you have not heard of them before, and some information about passwords as they relate to various compliance standards, which explains how sometimes we might end up with different types of password policies. I'll provide an introduction and some tips and tricks for Hashcat. Some of that information came from our team of hosts. Many of them also do penetration testing and use Hashcat on a regular basis. I'll also talk about how to get some password dictionaries and such. And then I believe Warren will do a full demo of Hashcat and crack some specific passwords. It's going to be a lot of fun. So over to you folks for a brief introduction and passwords and compliance.
Yeah, absolutely. Thanks, Paul. Appreciate the opportunity. Online Business Systems has been around since 1986, so just over 30 years, mainly focused in the application integration space until about 10 years ago, where we introduced risk, security, and privacy within that space. So a little bit about that. Now we've moved towards the digital transformation space and using cybersecurity. So a lot of our practices and services kind of fall into that realm. As you can see on the next slide, that we have over 350 consultants, both in Canada and US. We're privately held. Again, most of that focus has been coming in from the application side and digital transformation, introducing cybersecurity, where we have a lot of depth and breadth of experience, mainly coming in from VeriSign's global security consulting, and then going into Online Business Systems. We kind of focus our areas in three. On the next slide, we talk about different practice areas. So we have advisory services, assessment services, technical services, and then managed security services. And each of those different realms have different buckets and different spaces that you can see. And we kind of bring all of that together for this particular webinar and for this particular demonstration and aspect of things. So appreciate the opportunity to talk to you guys about this. I think this is an exciting space that Adam and myself have given this presentation with Warren a couple times, but this has kind of been flipped. So we're going to talk a little bit about the compliance side of this, the different compliance natures from PCI to Hipaa, and then to NIST, kind of where our recommendations go. Typically, the shock and awe is developing a password that gets cracked in the audience. And so this was a little bit different, right? So this is a little bit more deeper dive technical. And so a lot of that space is going to be given to Warren and his capabilities, and demonstrate that after Paul walks through kind of that normal installation. So I'm going to pass this over to Adam. Adam's going to talk a little bit about the different requirements from all the different ones, and talk a little bit about the differences there. Adam?
Yeah, thanks, Rob. So, I know many of you want to get straight to the password cracking part of it and Hashcat and all the technical stuff, but I hope you'll bear with me for a little bit because I think it is important to understand some of the context of why we're doing this and what some of the requirements are on the compliance side, and what things people can do. Kind of the entire takeaway here is, what can you do to protect your organization, and do it in a way that's both compliant and secure. And I'll leave that discussion about the difference between compliance and security to another time and day. But what we want to do is go through a few of them. Kind of with password strength, it's not all about uppercase, lowercase, special characters and numbers. We also want to make sure we're considering how we're storing our passwords, and that's going to get into some of the hashing algorithms that Warren's going to talk about. Also want to talk about usability, because the harder it is to use passwords and to use authentication mechanisms, the greater chance that users are going to try and bypass them or do things that actually make them weaker. And then we certainly don't want to ignore multi-factor authentication. We're focusing on passwords today, and that's great and important. But it doesn't negate the fact that for high secure systems, and actually many internet-facing systems these days, multi-factor authentication is important. So those are kind of the 4 buckets that compliance requirements and also design goals are built into. So if we start with PCI DSS, yeah, it's all right. We'll start with password strength. So here are many of the things we've learned about passwords, but actually, I hope by the end of this, you might find out a lot of what you've learned about password strength is not true. So if you look at PCI DSS, they want 7 characters, uppercase, lower, actually contain number and letters, change every 90 days, and can't reuse the last 4. So very traditional requirements, I would say. Not very specific on storage, no usability requirements, and then built in some multi-factor authentication. So if we kind of memorize that, take a visual snapshot of that, and then we'll move over to the next one. Hipaa. So this is where I live day in and day out in the healthcare space. You'll see Hipaa has very few requirements, and that's because Hipaa is not prescriptive in the way that the PCI is. So Hipaa basically says, do what's reasonable and appropriate. Hipaa has a bit of a different bend to it in that it's actually important that you don't hinder access. So getting to the data is just as important as protecting it. And then certainly your multi-factor requirements. So take another kind of visual snapshot of that one, and then we'll move over to the next slide. And here you see NIST 863B. If you're interested at all in password authentication standards, identity standards, make yourself familiar with this standard. It's the National Institute of Standards and Technologies. They've come out with an updated standard. I think it's maybe about 1.5 years, 2 years old by now, but still not fully adopted. Now look over at password strength. No complexity, no change, focus on length. So all that stuff you've learned, uppercase, lowercase, numbers, specials, changing it every 30, 60 days, gone away from it and focusing more on length. But also, you can't just take that. You can't just say, well, okay, NIST says go away from complexity and change. Now we're good. We're okay. We can just get rid of that. No, we still need to focus on storage and usability and multi-factor. And actually, there's one thing missing from the password strength one, and that's comparing proposed passwords against blacklists and breached password lists. So you're going to learn a lot about word lists and things like that here today. That's how hackers attack these things. So if we can make sure that passwords are long and don't have those common passwords in them, it helps a lot more than things like complexity and change. It also kind of helps the user, because all those things on the usability side can be added to it. And things like getting rid of password hints, letting users see their passwords and things like that are actually important for security. People don't always think of that. Storage, we're going to hear about hashing algorithms, so I won't go too much into that. But if you want to just kind of flip back between slides 1, 2, and 3 quickly, I want to kind of show the visualization of that. See how we go from strength, a lot of strength, not much storage and usability, and then back to slide 3. And then suddenly our requirements are moving more into storage and usability. So that's the direction we're going here. And that's hopefully the direction that, if you want to take anything away from the compliance standards, the topic from this webinar, that's the direction we want to go, and probably you can help out your users. And I know in healthcare, doctors hate passwords, so it's for us, it's always fighting against the doctors. So this can really help moving to this standard. But just remember, don't cherry pick, just one requirement. I'll get rid of complexity. You got to look at it as a whole.
Yeah, it's interesting looking at the shift to storage and usability. There are so many folks and organizations working on having passwordless authentication, which really eliminates that password strength kind of thing. Yeah. The strength transfers to a different type of technology, but I think that's an inevitable future for us. Yeah,
exactly. And it's kind of interesting that we're spending a lot of time today talking about passwords. And where the goal is actually to get rid of passwords altogether. And we're on the same page there. Unfortunately, fact of the matter is, it's still a huge part of our day-to-day life, and so it's important that, especially with new attack vectors coming in, that we're still addressing it.
Agreed.
So starting to get a little more into the technical stuff. These are some numbers that we actually put together based on our own testing. So we took 4 different hashing algorithms. Well, really 3. 2 of them are PBKDF2, but just different modalities. And did some testing for 6-character, 8-character, 10 characters. And this is brute force attack. So this is just trying every combination out there in the universe, which is usually not how we attack. It's not quite as efficient. But you look at 6 characters. You have a 6-character password. You can brute force that in just a nominal amount of time. It doesn't matter. It doesn't matter what hashing algorithm you use. And I stopped the chart here at 1 year, because if it takes you more than a year to crack a password, it's probably not very usable after that year. So we kind of stopped there. By the time you get to 8 characters, you see bcrypts off the charts. It's way more than a year. I don't know what the exact number was, but it was way off there. Same with most PBKDF2, but you got that one you still have to be careful with. By the time you get to 10 characters, all 3 of those are just completely off the charts. It's not even worth trying to brute force them. You see SHA-256, though. You see it's flatlined at the bottom there. It doesn't matter how long your password is. If it's hashed with a straight SHA-256 hash, now we're not using any salting here or anything, but just to kind of make the point, it's very easily cracked. And I think I hope I'm not stealing Warren's thunder too much, but that's just some of the numbers that we came up with, and it's kind of nice to see it in a graphic like that. Okay, and then one more thing, and I'll stop talking, and I'll let you guys get to some of the more technical training things. But this again is really important for context. First of all, again, a lot of what you've learned traditionally about passwords, maybe not true. Look at all these passwords that are PCI compliant, according to the standards that we saw in a slide earlier on. Password 1 with a capital P and a 1 at the end, PCI compliant. But guess what? That thing's going to get cracked in no time. Going through password, Michael, this one confused me. I don't know what it is about people named Michael or people like Michaels or what it is, but somehow Michael made the top PCI compliant password list. And then finally from this slide, there's actually research that's been done that shows that if you give people a requirement to have numbers and letters in their password, what are they going to do? They're either going to, if you don't require both, they'll just have numbers, 1, 2, 3, 4, 5, 6, 7, or they'll put the numbers at the beginning or the end. So people aren't computers, which is what the previous password guidance was based on. They thought people will think like computers and do some random combination. No, people think like people. They do a word, probably with a capital first letter, and then they stick the numbers at the end. So password crackers know this. They're not dummies. So they're going to take advantage of this. So really, these complexity requirements aren't actually helping us. All they're doing is aggravating users and making them write down and reuse their passwords. So that's some interesting things that some of the actual research has shown.
Fantastic.
So yeah, with that, I think I'll turn it over to you, Paul.
Yes. And it's interesting. So we'll talk a little bit about Hashcat to get everyone kind of up and running and show you some of the more advanced techniques that came from our team, as well as some outstanding additional resources that I found largely, from folks on our team like Black Hills Information Security and others. So the first step as we go through this virtual training is you got to get Hashcat installed, right? That's step 0, as it were. And I just wanted to point out for folks that there were some changes from version 4 of Hashcat to version 5. And if you try to take the easy route, like I did at first, I was like, well, what happens if I just go into my Linux distribution and I install the version of Hashcat that's available in most Linux distributions, especially Debian and Ubuntu-based ones? It's really easy to install, right? You get the binary, it comes down, and you get version 4, which is slightly older as well. You may also see some references to OCL Hashcat. There were 2 versions previously of Hashcat, one OCL Hashcat, which did took advantage of GPUs, and Hashcat that did not. They've merged those together some time ago, and we'll get into kind of my recommendations on how to not go down a path of messing up your system just to get GPU cracking. It's just some friendly advice. So to get the latest version, you got to pull it down from the Hashcat website. I pulled down the binary version. I didn't go through the exercise of compiling it myself. And in all of my testing, testing the various commands from our hosts, this binary version worked just fine on, I've got 3 different Ubuntu-based distributions that I use on 3 different computers, and it worked. Hardware aside, this process worked fine to pull down the binary version. Now, it does use libopencl as the interface to the various GPUs. So if you get an error when you install it on your system, one trick that I used was to install the OCL library, and at least on one system that fixed my problem and gave Hashcat the right interface and libraries to interact with the GPUs. But on some systems, you will run into problems depending on what kind of graphics driver that you have, whether that's an AMD card or whether it's a subsystem off of your CPU. I tested it on various systems and then started reading how you might get that running, and it's basically really ripping into the Linux subsystems and drivers and swapping out your graphics card. So my recommendation for this is, if you have Linux systems that have another purpose, for me, I have 3 Linux systems that I use as my desktops and my laptop. I didn't want to muck with the graphics drivers on those, right? Because those are systems I use all the time. You may have other systems laying around. You're like, oh, maybe this can do some, password cracking for me in the meantime. That's not what I recommend. I mean, it's fine if you have the graphics card there and you don't have to muck with the drivers. I had one system that's the way it worked. On the other systems, I was like, I'm not going through. I mean, if you read some of these instructions, having done Linux for over 20 years, I'm like, yeah, that's a path I'm not going to recommend people go down. So you can go hunt and find the right drivers and the right configuration to make it work. However, I recommend that you go shopping. And if you're going to do this, internally or as an external assessor, I do recommend that you build a dedicated system for this. And there's lots of great advice. So I recommend you go shopping for the right graphics cards. Those could be AMD or they could be NVIDIA. I think the GTX 1080 Ti's have come down a little in price. I saw them around $850 to $900, whereas before those same cards were probably $1,200. So you can get a little bit of a deal and a discount today on those cards. And I think we'll talk more about some of the hardware, and I have some references if you're going to build your own rig for cracking. And I think we'll also talk about how various cloud providers have this available in the cloud, and really why most people build their own, because basically it's still cheaper. So we'll touch on that a little as well. So once you get Hashcat installed, the first thing you want to do is to start cracking passwords, and you realize that in order to do that you're not necessarily, as we've said already, trying to go through every single iteration of every single password, right? We want to do a password guessing from a dictionary. And the first question you have is, well, where do I get good dictionaries from? Now, fortunately, I was able to pull a lot of this information both from my own research as well as from our teams that do this all the time. And I came up with these recommendations in terms of getting password dictionaries. Now, what's interesting, if we look at Skull Security, they've archived some of the data breaches that have passwords in them. Some of those are really old, but it doesn't really matter because we're humans, and if a dictionary is 6 years old, it's not like we're coming up with all these really new ways of using a password. So the crackstation.net has a gigantic basically tarball that you can download that's almost 2 gigabytes in size that archives much of the password lists from data breaches. Skull Security does the same thing. And then also on the slide are 2 resources for you to make your own password dictionaries. Sool from DigiNinja is a very, very great tool. It came out some time ago. It's still maintained, and a great way to point at your target's website, pull down a password list based on what's on their website to create a custom dictionary. Also, this is a recent project that I believe it was Tyler, one of our hosts, pointed me to. And this allows you, this is a PowerShell script that you point at Wikipedia, and you can choose the language that you want to generate basically a password dictionary based on the entire Wikipedia, archive in various languages. So if the site that you're going after is using a different language and you want to create a dictionary with that language, you can use this tool to create dictionaries from Wikipedia, which I thought was really awesome. And this GitHub repository was only a few months old. So this is a relatively new technique and really awesome. There's also rules that you can apply. We already talked about how humans in general, tend to substitute the same letters for the same numbers. There's all kinds of rules that you can apply to Hashcat that will automatically make those substitutions as well to enhance the dictionaries that you might pull down. Alrighty, so then the next thing you do, so you got Hashcat installed, you've got some password dictionaries. Now you want to try cracking them, right? So you have to either get some or generate password hashes. Now, if you're on an assessment outside of the scope of this virtual training, we're trying to focus on the cracking aspect. There's a number of different ways that once you've gained a foothold on a system to collect those hashes. Mimikatz being probably one of the more popular ways to pluck password hashes out of memory. That could be an entire, probably couple of days worth of training on Mimikatz. At first, I just wanted to make sure that, and you should do this too, make sure that your Hashcat system is working and crack some hashes. So I wanted to get some sample hashes just to make sure that it works. There is a website that you can generate LM and NTLM hashes and then save those out to a file. Hashcat also makes available some sample hashes just so you can make sure that the version of Hashcat you got can crack those hashes. Make sure that your syntax is correct when you're trying to crack a particular hash. So it was super helpful to have this just to make sure everything was working on my system, that my GPU was actually doing the work of helping me do these dictionary brute force attempts against these hashes. One interesting kind of little thing to make sure it works, you can take some passwords from your dictionary, right? You can paste them into the first website listed on this slide. It'll generate LM and NTLM hashes for those passwords so that when you copy those hashes down, you have the passwords in clear text in your dictionary that match the hashes to make sure that you can see the results, that results are going out to a file or the screen, that you can capture those. There's nothing worse than spending half a day cracking a whole bunch of hashes. The process ends and then you lose your connection to the system and your results are gone. So make sure that you test all of that, and there's some great resources on the slide to be able to do that. And now we get into some cheat sheet items. The first 3 examples here are some of the somewhat newer, certainly newer than LM or NTLM password cracking, ways in which you can crack passwords that you're pulling off of Windows systems. Now, what's interesting, I will link to a cheat sheet. Hashcat makes an index with the -M flag, and so those numbers represent the hash type. So in this first one, you see the type I've put there in the description. It's a Kerberos 5 TGS rep E-type 23. That's what -M 13100 will reference. So it's kind of weird. It takes a little getting used to that there is this mapping between the type of hash that you've collected and mapping that to the number. Again, I will link to a cheat sheet that was for version 4. But I found that most of that stuff in the cheat sheet anyhow transferred to version 5. If you run Hashcat with --help, it also spits out all of those mappings of the number to the hash type. And so you can see there's a couple more that are related to Kerberos using different techniques. And then, I threw in some other ones, like if you're going to crack PeopleSoft PS tokens, that's how you do that. And those question marks and letters and such, that's the mask. So that's how the hash is set up. So in the examples, you'll see that we've done some of the masking for you, so you don't have to figure that out on your own and be able to crack some things you might not run into every day on every test, but PeopleSoft is in there. And then, of course, Landman LM hashes. If you've got any kind of GPU, sparing you, I'm sure everyone knows how the LM hashes are super insecure. That was a long time ago that we discovered that research, how it splits it and converts it to all uppercase. Those crack really super fast on even not a really newer GPU. If you had a bank of 4 or 5 1080 Ti cards, we were just talking with Greg Foss, who's been on the show before, and he had this huge password cracking rig behind him. I think he had 8 cards. They were all 1080 Ti. So, I mean, you can get crazy with your rigs and really blow through, especially things like Landman or LM hashes. And just some additional resources that I used to create kind of the cheat sheets and get up and running. Many of these come from Black Hills InfoSec. They've done a great job of documenting a lot of the things that go into Hashcat. They cover how to crack Office passwords. So if you come across a Microsoft Office document that is protected with a password, there's 2 different posts on how to do that. There is also a nice blog from Rapid7. You can actually connect to IPMI services, remote management services. If they are vulnerable, they will spit out a password hash, and there's instructions on how to crack those. Umlauts, which are the different characters with the funky lines and stuff above them, can be problematic when you're cracking passwords. Black Hills had a nice post on how to deal with that if you run across them. And of course, different operating systems as well. A lot of this is very Windows focused, but you may run across an OS X system, OS X or Mac OS. There are very specific instructions for the version of either OS X or Mac OS that the commands you have to run to be able to extract those hashes, and then how to use Hashcat in order to crack them. There was some great posts and resources on how to do that. Okay. With that, I will turn it over to Warren to run through our demo today.
Hello, everyone. I am going to be switching over to my screen real quick. All right, hopefully everyone can see that all right. So I'm just going to be going over Hashcat kind of in action, showing like how easy it is or how hard it is to crack certain password hashes, giving a kind of overview of if you have Hashcat, how to like search the help file and everything. So first we'll go ahead and get ourselves a hash. So I'm just going to generate a SHA-256 hash. I've created like a random character here, like a random character set, just to show it's a 9-character password, to show how even at like that upwards of like 9, 10 plus characters, SHA-256 can be pretty quickly cracked. So here we've generated our hash. So this is a fixed length. So no matter how long we take this or make this, the algorithm is always going to create the fixed length hash. So just to show how even modifying a little bit of it, so changing just one character, like changing this R to a T, actually completely changes the hash, just to make it so that it's a little bit harder to figure out. Like if you have a password that changes just a little bit, it's not just like an incremental thing. It completely changes everything about the hash. So we are going to go ahead and put this into a text file so that we can show the cracking in action. All right, so let's make sure that we have that. So we've put our hash into the text file. So I have some commands just saved over here. All right, so we'll just go over this command a little bit. So I know Paul mentioned going over, like, you have your -m here to specify the hash type. You have a -A3. This is to actually specify the attack type. So this is a mask attack. So we're taking a series of characters and just trying to brute force. Just pull up the help file here. So if you do hashcat space -h, you're able to pull up the help file. And we'll just go over what this character set means right here. So as we went over earlier, people have like a tendency to choose their passwords very specifically. So here we know people tend to try an uppercase letter for the first part of their password. So we do a question U, and this will do all letters from A to Z with capitals. Then we're doing 5 question mark L's. So this is specifying that there are going to be 5 lowercase letters. Then we are doing 2 question D's, and this is specifying that these are going to be numbers from 0 to 9. And then people tend to throw that character on the end of their password. So we're doing a question mark S. So let's hope the demo gods treat us nicely. We're going to go ahead and start this cracking. Yeah. All right, so Hashcat's starting up. So now we can press S to show the progress of our cracking. So we can see that it's going at about 12 billion hashes per second right now. And it has our mask specified, and it's going to take a maximum of 1 minute and 22 seconds right now for our SHA-256 hash. So we can see it's already finished, and it already found our random password that we created. And this is just to show kind of the weakness of SHA-256 without any salting or any other increased complexity to it. It's just Hashcat is able to go extremely quickly with even like our cracking boxes for 1080 GPUs. All right, so we know most people tend to not choose random characters like this for their passwords. So we're going to go ahead and take an example showing that it's using like a real word. So here I have changed it to winter 2020. So if you've ever done IT or used Office 365, you know that when you generate random passwords for people, when you're doing a password reset, it'll set like a July or January or winter, summer, and then put the year afterwards. So as an attacker, it's pretty common to try to look for that as a password. If you just to like kind of guess that IT might not be changing passwords as often as they should or stuff like that. So we're going to go ahead and create that hash. And then for this, we're going to use a word list based attack. So as Paul mentioned before, you can generate your own word lists. We are going to use a really common one called RockU. This was from a breach years ago, and it's just, it has a large amount of common passwords. So we changed our -A3 to a -A0 so that we're now specifying that this is a word attack or a word list attack, dictionary based. And then we are giving the word list at the end of it. So we'll go ahead and give this. So if winter 2020 is in that word list, then we will actually get the password pretty quickly because it goes quickly through a word list where before it would be trying a large amount of passwords. So here we can see it exhausted it and did not actually find the password because winter 2020 was not actually within that word list. But it went very quickly to actually go through it. So we're going to change our attack up a little bit here, and we're going to add what's called a rule onto the end of it. So this is a list of modifications that Hashcat will make to the dictionary and actually change like characters and add numbers and modify it in specific ways that people tend to do passwords. Like there's one out there called the Leet Speak word list. So it'll actually change characters like an A over to an @ sign, change an E to a 3, just things people tend to do to try to make their passwords more complicated. So we will go ahead and run this and see if modifications to this will actually make the Rocky word list more successful in this attack. So there's a ton of different rule sets out there. You can find them pretty much anywhere in the wild. All right, so we can see it's already finished, and we actually were able to crack it this time. So Winter 2020, when we didn't crack it originally with the Rocky, by adding a rules file on, it likely added on the 2020 at the end or modified Winter 2 or something like that to be able to actually find those characters on the end. The one that we use...
Yeah, which rules file were you using, Warren?
We were using the Dead One rules file. It's a pretty common one out there. You can find it if you just Google Dead One. There's whole lists of rules files that modify in different ways, and I'm not actually sure how this one specifically does it, but I tend to have a lot of success with Dead One.
Dead One, gotcha. And that's something you acquire. Go ahead, sorry.
So yeah, it's D3 AD and then 0 NE. So it modified like the 3 and the O is in the...
Gotcha.
The way I said before, how people tend to like change characters to try to make it more complex.
Right. And that's one that you found somewhere on the internet and put in your word list directory. There are ones that come with Hashcat, but you've had better success with some of the external ones.
Yeah, I'm not sure. I think this one might actually come with Hashcat, but I can't recall whether it does or doesn't. But there's a whole set of lists that will come like pre-installed with your Hashcat install.
Gotcha. Now, in practice, Warren, you're probably always using a rules file when you're doing it on a pen test, right?
Yeah, we're pretty much always using a rules file. I mean, sometimes you'll be successful with just like a word list. We use a lot of one called Weakpass 2 out there. It tends to have a ton of passwords, but you almost always want to throw in a rule file because it just increases your chance and doesn't really impact your crack rate that much. Yeah,
I was going to ask that. So with 4 1080 Ti's, the impact of using rules versus not is pretty minimal.
Yeah, it depends. Like if I'm using Weakpass 2, which is a much larger rules file, or not rules file, dictionary file, then if I add a rules file onto it, it could increase the amount of time it'll take because of just how many more modifications there are. And there's other rules out there. Someone's done one called one rule to rule them all, where they've basically taken a list of every single rules file and determined which ones are the most successful, and then putting those rules compiled into a single list.
That's awesome.
All right, so we've seen how it can be pretty easy to crack like a SHA-256. Like it can take you a matter of seconds to do that. So let's see like a more complicated password. I'm going to go over here.
Warren, one question on the SHA-256. Which common applications use SHA-256 as an algorithm?
It would be like a lot of web apps and stuff like that in the past.
Gotcha.
It's not very common anymore, especially like one that hasn't been like key stretched or anything like that. You can see SHA-256 used in a lot of like encryption keys and everything, but it's used with something else.
Gotcha.
And then like even Linux used to use it, but they used a crypt version of it. So it actually is stretched a little bit more and it's more complicated to attack than just base SHA-256 sum, which is what we're creating here.
Right.
This is used more for like hash comparisons and stuff like that. Like if you're trying to do checksums and stuff like that.
Gotcha.
So I'm going to create like a more kind of complicated password here. Let me just zoom in here. So I'm just using kind of a hack here, HT password, to create a bcrypt password hash. So we've taken that winter 2020 again, and we're using a stronger algorithm here. So this is actually bcrypts, which takes a hash and then hashes it again, and then hashes it again, and hashes it again to make it more complicated. So if you are trying to crack the hash, then the tool has to go through like multiple iterations of taking a hash and then cracking it, and then cracking again before you can actually find a password.
Mm-hmm.
So we're going to go in here. All right, so we've created that hash, and now we're going to try file again. So I've changed the -m over to 3200. We can see over here, if we grep for bcrypt. So bcrypt is the Blowfish Unix. It's what the operating system itself hash passwords for. So if you were able to get in like a shadow file or something like that. But a lot of different applications use it today because it's far more secure than using like a SHA-256 sum, for example.
Gotcha. Yeah, there is an audience question, Warren. Why hasn't SHA-256 been eradicated or deprecated? I mean, largely it sounds like it has, but there's legacy applications and operating systems that use it.
Not really operating systems, but I guess some like really old applications might.
Gotcha.
I'll jump in there. I think we see it a lot with custom developed applications. According to the NIST standards, it has been deprecated.
Gotcha. Thank you.
Yeah, it's what's called like a fast hashing algorithm. So if your application has a lot of CPU need, for example, so if someone's creating a password and you're encrypting it or hashing it in SHA-256, it's very quick and doesn't use a lot of CPU resource to be able to store that password. But then if we use something like bcrypt, it's the key stretching part of it actually makes it so that it has to be rehashed over and over again before it actually generates password. So it's more CPU intensive. So if you have an application that is using a lot of resources, it can be very intense and can actually cause like delay for a user while they're creating their password. So this is often where you see CAPTCHAs and stuff too while you're creating your password. It's to create a delay so that your password is being hashed in a more secure algorithm.
Right. Now, do you control, this relates to an audience question, how many times it's hashed with bcrypt? Is that configurable in some systems? And the question is like, how many iterations would you suggest?
I think this is something that you can kind of modify within your own application. Like, I'm not sure how many bcrypt does or any of the other crypt algorithms. There's also like scrypt out there. But some people have custom built their applications to be able to go through as many iterations as they want to.
Yep.
And they just, based on their CPU needs and everything, they're able to custom build it in that way.
Gotcha. Yeah, so balance with performance.
Yeah, and that's in the NIST standard too. They've got a discussion of that where you do want to tune it so that it doesn't have too much of an impact on performance, but you can do as much as you can without impacting performance. I think a baseline they threw out there was maybe 10,000 iterations.
Yeah, so you can see 10,000 iterations would make it extremely difficult.
Gotcha.
So let's go ahead and run this and see how it looks. See how much longer it will take Hashcat to be able to do this than it would a little easier. Oh, I guess I did not load that properly.
A couple more audience questions. Can this all be tested in a lab on a VM?
Oh, absolutely. Okay. If you're able to add your VM, if you have a GPU. You could even use a CPU for Hashcat. It doesn't have to be GPU based. It's just going to be much slower cracking.
Mm-hmm.
All right, so let's actually see. Sorry, I need to hit S.
I think we answered this. Your GPU is a 1080 Ti, and you have 4 of them, correct?
Yeah, we have 4 1080 Ti's.
Gotcha.
Or not Ti's, sorry. We just have regular 1080s.
Gotcha. PBK DF2 versus something like Argon 2. Those are similar to bcrypt, right? In the same category of how the passwords are stored, correct?
Yes. Yeah, they're similar in the category. So they're not just storing the hash itself. They are storing it in a more complicated way, such as rehashing it multiple times.
Gotcha. So the PBK DF2 and Argon 2 are different ways to store the password, such like bcrypt, where they're hashing the password multiple times. That's the way I understand it, correct?
Yep.
Okay.
All right. So we can actually see here, bcrypt, same password, winter 2020, using the same wordless and rules file is now going to take us 5 years and 298 days estimated before it's going to be able to crack it, where the other one was taking a matter of seconds. So this just shows like the power of just running your hash through multiple times, or the different algorithms to be able to stretch your key to make it more complicated.
Yeah, and that's one thing I always look for when I'm testing an application and or developing an application is how the passwords are stored. I make sure that it's using either bcrypt or PBKDF2 because of that sharp contrast in terms of cracking times.
All right, and that's everything from my end. Actually, real quick, I wanted to show kind of, since you mentioned CrackStation earlier, I wanted to actually go in here and show that you can actually take a hash, and this uses what's called a lookup dictionary. So like CrackStation has actually saved like tons of hashes, and they're able to instantly look up. Okay, so here it actually did not find our winter 2020. So
no, that's pretty.
It's not a very good example of it, I guess. But
so, yeah, they've basically pre-calculated all of the hashes and created a lookup table, right? There's been sites like that for forever. There's been sites like that. The danger being is that you're potentially giving your password off to a third party. Or if that site's compromised, right? It could do things. Yeah. The third-party services for cracking are kind of, I think that's one reason why you want to have your own system to do this, because you can do it safely because you're handling people's passwords, essentially.
Yeah, most of them won't store a username, though. They'll actually keep you from storing a username, but they'll just store the hash. So people will still be able to look it up, but they won't know an actual username with it.
Sure. I've just got a few more questions, Warren. So have you seen pushback from corporations not wanting to eliminate password expiration even after implementing two-factor because that's just the way it's always been done?
I think that's a good question for Adam, probably.
Yeah. Short answer, yes. I mean, people have these preconceived notions ingrained in them, and actually, to be honest, there has been the one kind of sticking point of the new NIST standards has been the password change requirement, because a lot of security practitioners do still see a lot of value in it. For example, Warren was just showing, hey, maybe they haven't changed their password in like a year, so we can use some old passwords. So there may be still some value in it, but I think it's a matter of weighing the usability versus the security it provides. And so if we layer in those other controls, maybe the password change isn't providing us as much.
Have you used a Mac with dual graphics cards? Someone says they've always had trouble with that.
I
have not. Yeah, I've not tested it on Mac.
Our box is like a standalone, and it's running on Ubuntu.
Yep, and that's
flip the slide there, Paul. We have the specs on the next slide.
There we go.
Yeah.
So let's talk a little bit about the hardware.
Yeah. Go ahead, Adam.
Yeah, actually, So the previous slide was because we were doing a kind of perception versus reality. So that previous slide was the perception is that these password crackers have these huge supercomputers, and it's some guy who looks like a Viking off in some other country doing it. But in reality, and unfortunately our image didn't load there, but we've got a 1U server that we probably bought off Newegg. It's just the key to it is the 4 GPUs. But again, it's just open source software. It's nothing magic. And that's really all it takes to do some very effective password cracking that we've done. I know, Warren, you put those numbers together. I'll kind of let you talk to those to compare doing it on your own hardware versus doing it up in the cloud.
Yeah, so I put an example here to show that like if you were to build yourself an enthusiast rig using like 4 2080 Ti's, which is like pretty much top of the line that you can get, they run about $1,200 each. And then you're probably going to want buy a server and everything to put them in. So it might cost you around like $6,000 to be able to get like a full rig built of just that. That's just kind of a guess. I'm not actually sure if that's the exact price. So that would be like a one-time fee, and then you'd have to plug it in and do some, you'd pay for power and everything. But then you have over here, you have a P3X large instance that's in AWS. So that uses 4 Tesla V100s, and those are really like powerful cards. They're like $6,000 each or something like that, maybe a little bit less. And that costs $12.24 an hour, and is going to crack hashes at the same speed as your enthusiast rig. And it will take you about 480 hours, I believe I have up there, to be able to until it's going to cost the same as your own rig. So you could use AWS to be able to do this. And if you're just doing it like a spot thing, like a couple hours every month or something, it would take you a long time before you're actually going to need to buy your own like enthusiast rig. But if you're doing it very frequently, like we do for our a lot of our engagements, then having your own server built and everything is going to be probably cheaper in the long run.
What kind of power supply do you need to run? Like a really powerful one, right? Like you're talking above 800 watts, right?
Oh yeah, you're probably going to need above 800 to run 2080s.
Yeah, I think PCPartPicker.com, and I haven't really validated it, but it will, as you add components for your build, start to total up the power consumption requirements so that you spec out the right power supply. I like PCPartPicker.com. We build a lot of systems here for different things, and I use that site, and that'll tell you you want a big power supply. If you're going to power, even 4 of these graphics cards, right, they're going to consume a lot of power, and make sure that you're cooling it efficiently as well.
Be ready for that power bill.
Yes, it's gonna draw some power. And then any recommendations for motherboards that can handle multiple graphics cards?
I'm not sure entirely. I haven't really done the research on which motherboards you'd want to use for like a custom rig.
I know Black Hills InfoSec had a post. If you search the Hashcat tag on their website, they had a post. It was an older, maybe a year ago or so, and had the motherboard model listed there. So you could find similar ones.
Yeah, you'll probably be able to find a lot of resources out there because similar rigs are used for like mining cryptocurrencies. So you'll be able to find, if you want like 4 to 8 GPUs, what type of rig you'd be able to buy. Some people have like pre-built actual systems out there with for like cases and everything to be able to hold those.
Yeah, and one thing I've made this mistake before is when you look at your CPU cooler, make sure that if you buy the really tall ones that there's clearance in your case. So actually the self-contained, I think a lot of us have made that mistake, right? And a couple of times I've had to take out the Sawzall to modify my case. But the self-contained liquid coolers for CPUs, and they also make models for GPUs as well, because your GPUs are going to get hot as well. They've come way down in price and work extremely well. And my more recent builds are all using self-contained liquid coolers for the CPUs. And the nice part is you get a lot more clearance in your case because it sits on top of the CPU. It's low profile, and then the hoses essentially connect to a radiator with fans on it that you can mount somewhere else in the case. And I really like that design. Let's see. More questions. Is there a password policy / standard that you would recommend, keeping the balance of security and user experience?
So,
yeah, go ahead, Adam.
So again, I'll go back to those standards. I mean, it's really a matter of what systems you're using and what they support. If you have something that supports using the blacklists, and if you're building your own system and you can do a lot of the usability stuff, I would recommend going with the NIST standards. Password length will vary, so I don't want to give a specific number, but you can just see from the data what numbers and how they affect. It also depends on if you are making this available to the public or if you're using it internally just for employees. So if you're making it for the public, then you want to make it a little more usable. If you're using it internally, then you want a little higher security. Also look at integrating into centralized authentication systems that can make your systems a lot more extensible without a lot of custom code.
And
Gotcha.
multi-factor. Yeah, multi-factor is key.
Yeah,
Even for internal.
Absolutely.
If you can deploy that and implement that, I think that's the right way to go.
agreed. So when Warren, when you showed the time estimated when you were doing the bcrypt, that's a proposed key space exhaustion time, right?
Yes.
And so the question is, that's not the actual time. It could vary within that window, right? You might get lucky.
Yeah.
I've been in that situation before where it tells me it's going to take, in my case, it was days, right? But in the first 20 minutes, I got the easy passwords, right? And we run into that situation quite often. But it
really depends where within the word list the password might be.
Right.
So like we saw with that search, like I did crack it when it was SHA-256. So it is within that word list and it would have been found eventually.
Yes.
But where within those 5 years, you don't know. And would you really want to wait 5 years?
Right. Exactly.
And it's also dependent on the hardware too, right? Warren?
Yeah, absolutely.
Right?
Dependent on the hardware. So like if we had 4 2080 Ti's in our box, it would have doubled our cracking speed. So that may take like 2.5 years instead of 5.
Right. Yeah. So there is some very concrete math with that because of the way GPUs work and the way the software works. Correct.
Yeah.
Correct.
Outstanding. This is so much fun. So nerdy. You get to build computers and crack passwords. It's really awesome. I think I hit everyone's questions too, which is great. And if there's any final questions, we do have 2 minutes left. Anything else that you folks would like to add to our discussion? Let's see what else we got for slides here too.
Oh, just our contact again. Your basic general, contact us if there's any further questions whatsoever. But other than that, Paul, I think it's been a great demonstration.
A couple more questions. Does each GPU do the work, or does it use Crossfire for load balancing?
It kind of splits the workload among the different GPUs. So Hashcat uses multi-threading, so it's able to use multiple different resources and spread it across. So you don't really need to do like a Crossfire or I don't remember what NVIDIA's version is called, where you link them together.
Right. Yeah, I can't remember either. But the
SLI.
SLI. The way I understand it is that GPUs are a dumber processor, but much faster, right?
Yeah.
And Hashcat does the work of basically spreading that out across all of the available cores across the GPUs.
Yeah, the GPUs just have a large amount of resources available for Hashcat to utilize, and it just spreads it across those. So like if you're actually on your box, you can type NVIDIA-SMI if you're using NVIDIA cards while your cracking is going, and it will actually show you like how the workload is balanced. Like it's using 98% of this one, 99% of this one.
That's cool. So someone that's just getting started in cybersecurity, the question is, do you specialize in this cracking, or do you work with a team? Is this like your main task? Like, how does it fit into the pen testing team?
So the cracking is just part of what we do. So like if we're doing a web app pen test and we're able to use like SQL injection or something and get into the database and actually pull like a passwords table, we might find a whole bunch of hashed passwords. And then we'd want to throw those into the Kraken and wait until we're getting some passwords to help us progress more into the pen test to see how far we can go.
Yeah, it's a resource for the pen test team, right? You build the box. There's
Tool in the toolkit.
Yeah,
no one's really dedicated to it. It's just part of what we do.
And it's probably pretty easy to maintain, right? Once you get it all set up, there's really not much. I mean, other than keeping up with operating system updates on it, there's not much you need to do.
Yeah, updating Hashcat occasionally too, because Hashcat frequently adds new hash types. Like recently, PMK IDs were added like a year or so ago, which was a new type of getting WPA2 passwords. Before you would actually have to try to intercept someone logging in, and now you can actually just hit the access point and grab the PMK ID. And that was added just a couple of years ago or so.
Gotcha.
Yeah, just open the door, throw in a slice of pizza, and close the door, and that's basic care and feeding.
Right. Well, that's awesome. Well, thank you everyone for an outstanding virtual training today. Thank you everyone for tuning in. Of course, you will all receive a copy, a link to this video recording, as well as a copy of our slides as well. So you get all those wonderful commands and help that we put into the slides to use as your own reference. So thank you everyone for tuning in today.